That's fine. Okay, cool. So thanks everyone for attending. Let's go ahead and get started. Today we're talking about rentable NFTs. To get started, basically just going to touch on the agenda. We're going to be chatting with Jesse here from Double Protocol. They're the creators of the rentable NFT standard, ERC-4907. And then once we kind of get all of his knowledge and wisdom, we're going to hop into actually coding one together. Cool. So Jesse, I guess to get started, you want to just give a brief introduction of yourself?
Okay. So my name is Jesse. I am the researcher at Double Protocol, which means I'm not a dev. Full disclosure. I'm kind of like a generalist there. Like sometimes I do some of the writing. Sometimes I do some of the on-chain like data analytics stuff. Sometimes I help the BDs. Sometimes I do marketing. And here I'm just here to help talk about ERC-4907, which happens to be a standard that we proposed and we pushed it to final. And so I'm guessing that's why I'm here. So
yeah, definitely. So do you want to tell us a little bit about Double Protocol then?
So Double is a decentralized NFT rental protocol designed specifically for utility NFT. So utility, it's like anytime you can finish that sentence, I will use this NFT to. So to do something, then it has some utility, right? So this includes like some of the use cases include like metaverse land, game assets, just anything that you would use the NFT to rather than just as a picture in your wallet. So we're building a marketplace for these kinds of transactions, but it's primarily rental, but there are other things you can do with like tech. When we talk about rentals, our tech supports like all kinds of other transactions too. Anytime you're trading the usage rights instead of like ownership of the NFT. So this includes like subscriptions, reservations, rent to own. You get the idea.
Very, very cool. So obviously today we're here to talk about the rental standard. Can you tell us a little bit more about ERC-4907 specifically?
So the rental NFT standard ERC-4907 is an extension to ERC-721, which makes it easier for like those NFTs to be rented. So it really only does two things. It's really simple. It only does two things in about like 30 lines of code. It adds an additional user role in addition to the ownership role. So what I mean by that is that it adds like another address that the NFT records that represents somebody who has the right to use the NFT, but who does not own it. And so there's a few functions that interact with that. And the second thing it does is it adds an expires function, which is basically like a timestamp that signifies when the user loses the right to access the NFT. So it's kind of like the end of a lease. It's really useful for rental transactions because usually when you give somebody usage rights, it's temporary. So you need a way to expire it. So what you get right out of the box when you adopt ERC-4907 for your project is that the owners of the NFTs can like delegate others to be able to use their NFTs for like games, event access, or any other kind of utility, and then without ever losing like ownership. So some analogies, this is kind of like what you can do with ENS. Like you can like designate like different roles, like somebody else who can like change their address and stuff, or like it's kind of like giving your car keys to a friend for the weekend, but like without the risk of them like wrecking it. So of course, anybody can build rental transactions on top of it, and that's basically exactly what we're doing here at Double.
Okay, very, very cool. So, what was kind of the motivations behind proposing the ERC-4907?
So the motivation, when we're planning out to build like the rental market, like we looked at a lot of different ways to do NFT renting, and like we were kind of like dissatisfied by what we saw. The architecture of like 721 tokens just didn't really seem to do enough to support these types of transactions. And so you see a lot of projects rely on like collateral, like centralized Web2 structures, or like really doing backflips with like ultra complicated contracts that really didn't support permissionless interoperability. So we were, but we were also inspired by some of the stuff that we saw with like Decentraland land NFTs and ENS names, both which had like a pattern that would eventually turn into the dual roles feature of ERC 4907. And we thought it was like, wow, this is something that like pretty much all NFTs that want to like have rental functionality should have, and that was kind of that. Like after this, I guess I can link an article about like the like a rationale and like the and what we saw when we found when we were looking at other like implementations of renting.
Okay, cool. I mean, you can just go ahead and link it in the chat. Are you able to type here?
Yeah, but like which chat do I link it to?
Oh, are you not in the studio?
Is it there's a private chat and there's like a message from there's like a on YouTube, right? I can also
Yeah. So,
it could just you can find the link at some point. I guess we'll figure it out.
We'll
Yeah.
pass it up. Oh my god,
Mm.
this is crazy. We're trying something new. You guys are all part of the process. That's fine. Okay, cool. Yeah, so I mean, kind of what was the process like for proposing those challenges for those of us at home who are considering, introducing our own standards? Do you have kind of a story behind it? Helpful advice?
So are you talking about the process of implementing it or the process of like pushing the standard to final, like finalizing
Pushing
the
the
standard?
standard to final, like kind of shepherding that process.
Oh yeah. So the process was like pretty fast for like standard. Like it went really smoothly. Like we were surprised. Like we got it finalized in about like 3 months.
Oh,
Um,
that's fast.
yeah, it was really smooth. Like I think it was because like we had really good communication with the EIP team. And so yeah, and it's a pretty simple like in standard like technically. But like one challenge we did have was with like the semantics of the standard. Like for a long time we were considering using like renter for the second role, but we settled on like user because I think it's like more of like a general word, and like the standard has like use cases like free trials that don't involve financial transactions or like renting. So I think user was good. So but overall it was pretty smooth.
Okay, cool. I mean, I feel like at some level went by really fast. We had talked about this earlier,
Hmm.
but so NFT NYC, for those of you who were there, was like a bunch of token gated parties. And I was so sad because I'm like, I don't have an ape. I can't attend this event, blah blah blah. And I was thinking, damn, if I had like if I could just run this NFT for a little bit, maybe this is great. So I want to say at some level it's moved faster because of people like me who just FOMO into wanting to like access these exclusive things. But I think you had also touched upon like you think its use cases are what like more for GameFi and like metaverse, right?
Hmm. Yeah, but that is an example of a use case that we completely support. Like its utility, like our support is like very broad. So if there's like a project that's like, okay, we want our users to be able to like rent out their NFT to allow like access to these events, like that's something like it's perfectly fine for us to support.
Yeah, yeah.
Yeah.
So I guess before we start like talking about
Hmm.
kind of going into the implications of GameFi, I actually wanted to step back. We talked about challenges, the process of doing it. I guess there weren't really any challenges; it was smooth. But can we dive into like how has the reception been? I guess since the introduction, it's relatively recent, so
Yeah,
I don't know how much
I
data.
think it's like the most recent. If I
Yeah,
remember
yeah,
correctly, it's the
number
most
30.
recent.
Yeah.
Yeah. Um, it really blew us like away. Like the reception, it like was beyond our expectations. When the standard was finalized, of course, like we did our own like marketing and like we did like publications, but there were also publications about it like around the world, like without us doing anything. Like people are really excited about the standard. Like there were in like a ton of different languages that nobody on our team speaks, like French, Japanese, like
Oh,
Korean,
yeah.
and like so it's like all over the world, and like even our competitors are like, yeah, we're adopting this, we like it, and we're like, okay, yeah, and so all in all, we're pretty hyped.
Okay, yeah, that's really great. I mean, ERCs I think are my favorite part of the Ethereum
Yeah.
community. If I'm gonna nerd out about it, it's like really weird, but that's my fun fact, I guess. Okay, so like obviously reception has been really great. Kind of question, when we're building NFTs, right? So we have existing ones on chain. what does it look like for existing NFTs to become rentable? Is that possible, right? Because that kind of violates the immutability aspect of it.
Yeah, absolutely, absolutely. So like there are a few things you can do. Like so like of course, like if your contract is upgradable, you can upgrade it. But if you can't or like don't want to, there's also like a wrap solution where you like make a separate contract. Like what so like whenever a user wants to list it for rent, the 721 token would just like be run through that contract, and like a 4907 one like comes out like kind of like wrapped ETH. So like it's already being implemented. It's already been implemented. Like one of our partners, the play to earn game Warena, has already like adopted and implemented it. So it works.
Oh, very cool. Okay. Yeah, so let's actually dive into the GameFi metaverse right now.
Yeah.
Can you just give us kind of a brief overview of what those two concepts are?
Yeah, so when I saw this question, I was like, okay, like everybody has like a different like definition. Every like you ask a lot of people, they'll give you a different answer. Like my answer maybe might be a little bit different.
Okay.
So like GameFi is like whenever. So my definition of GameFi is like whenever something in a game has like monetary or speculative value with like an economy and like secondary markets built around it. So you might hear a lot about it. Like when you think about GameFi, you might just think about like play to earn games, like Axie Infinity. But I think it also includes like RuneScape economies. It includes like markets for CS:GO skins or like boosted League of Legends accounts, or even like Magic the Gathering cards. Um, so that's kind of like GameFi in general. So there's a lot of room. There's a lot of room in this space that's still yet to be explored. For metaverse, like my definition of metaverse, like I think like we're talking in the metaverse like right now. It's like it's the alternate internet world where like people like can communicate, interact regardless of distance, and like where and importantly, where like virtual things like matter more than physical ones. The only difference between like the metaverse today and what it will be like in the future is like it will be more immersive, and both from like a UX perspective and like a financial one. So that's kind of my take on these concepts.
Yeah, I really like that last piece you touched on. I think kind of when I define metaverse and I guess kind of onboard the naysayers to it, I'm like, metaverse right now in its current iteration is going to be like Zoom, Google, like Google Meets or Hangouts, I think, like YouTube Live, what we're doing right now. So just like imagine that in a more immersive environment. I mean, especially with like remote work going on, stuff like that. But I mean, that's kind of a separate portion, right? How do you see like this new standard rentable NFTs fitting into GameFi and the metaverse?
So a really big problem within like GameFi and like metaverse projects is like in the short term, like it's like liquidity. Like not everybody wants to or is able to buy like a piece of land or a game asset for like upwards of thousands of dollars. And like plenty of people will want and do want to rent them so they can like use them for like to play the game or to like build something on top of the land. So we see the standard as making it easier for those assets to be rentable, and to like and which like would increase like engagement and like accessibility of these ecosystems. And then it's also permissionlessly interoperable, so like other people can build like these markets on top of us like us. So because of these because of the standard. Yeah.
Okay. Yeah. So I guess just to briefly wrap up here, how can our audience get involved with double protocol, renting, I guess this kind of sphere of expertise?
Yeah, so like if you're thinking about having your NFT rentable, like I would highly recommend adopting ERC-4907. And like plenty of documentation, plenty of articles like on the web around it. Like we'll also include links. If you're interested in learning more about like what we're building, like at Double, you can find us on Twitter at Double Protocol, and we have a Discord chat. You can even try like our platform at double.one. We're live. And like you can read our docs at docs.double.one. And oh yeah, you can also like follow me at olesnakey, OLESNAKEY on Twitter. So that's my personal Twitter handle.
Cool. I mean, I was looking a bit into Double Protocol. So for like devs who want to integrate it, it's like you mentioned like documentation, right? So it's like an open source project, right?
Right now, yeah, the contracts are open. So we're working on like an open like self-serve kind of thing where you can just like integrate. That's something that we're working on. It'd be best if you guys like contact us, and we can actually help you through like integration for your project. And of course we have like our documentation. Yeah. So
Okay.
yeah, it's
Very cool. Okay, so last piece, I think my thing that I always like to ask everyone is, do you have any recommendations for the new people trying to get into Web3?
uh it's hard. It's like advice giving and all of that. Like
Yeah.
yeah, I don't know. It's like I think I would I would say just like don't be like too intimidated by everything. Like vast majority of people are like new, trying to learn from the people who are not. But we're all just trying to explore the space together, and so we're not just don't be too intimidated by like all this jargon or all of like the knowledge that you want or need. Yeah, it's something I'm working on too, but because like yeah, everybody like every vast majority of people I talk to, it's very new space, very exciting.
Yeah. I mean, we were also talking about this yesterday. I just want to like briefly touch on like how
Yeah.
I was like, oh, I got into Web3 because no one knows what they're doing. So like for those of you who have really bad imposter syndrome, like Web3 is a great place to be because everyone is like kind of confused. And I think it's like also a really cool time to get in because I was also having a conversation with my friends the other day where it's like, guys, we're gonna be the OGs in like 2 years. You know how like when someone's been in since 2017, you're like, wow, you've been around for so long. It's like, well, I guess 2022 is now the year. But yeah, okay, so I guess that's all the questions I had for you today. Unless there's anything else you want to add, feel free to hop off, and then we're gonna jump into actually implementing the standard together.
Yeah, while you're doing that, like I wanted to like stay in the chat a bit, see if there's any questions about
Oh
any of it.
yes, I
Yeah, like
forgot.
how do I do that? Yeah.
Okay. I'm not sure what view you have as a guest, but if you want to just like
Uh,
sit in YouTube
yeah,
or
I'm in
something.
YouTube. Let's see. I'm in YouTube. Is there also like a Twitch? Like where are people at
There
right
is a
now?
Twitch. I don't think that many people are in it. In terms of questions, I guess just direct them to YouTube for now.
Okay, sounds
Um,
good.
and that will be it, I guess, for this
Okay,
portion
cool.
of Double
Yeah,
Protocol. Yeah,
sounds good.
thanks so much for joining.
Yeah,
Yeah.
my pleasure. Yeah, I'll be in
Okay.
the chat.
Well,
Watching you code, I guess. Yeah.
oh no, you're gonna be like, Emily, you're implementing everything incorrectly.
No, 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 no,
And
no.
I was like,
I'll just
okay,
be,
well,
oh my god, you're coding.
yeah, leave some critique afterwards. You're like, wow, you did it correctly. Oh my god. I mean, you guys had really good like documentation. The EIP was super clear. So I will jump into that portion. I'm gonna go ahead and start sharing my screen.
Okay,
Here we
so I'll
go.
just hop off then. Like, see ya.
Yep.
All right.
Okay.
Yep.
See ya. It was really good hanging out. Okay. Cool. Now I guess where are we gonna go? Here. Okay. Sharing my screen now. Let us. We finished talking about rentable NFTs with Double Protocol. Let's start coding together. So first off, installation instructions, getting our environment set up. Again, Truffle is going to be our deployment tool of choice. Ganache is going to be our local test chain that we will be testing on. Once you want to kind of test it on your test nets, Polygon, going over to mainnet, that's when we'll need the Infura account to come in. Then MetaMask, VS Code extension is my IDE. Of course, we'll need test ETH. I use Paradigm's faucet. So we can go ahead and get started. Blah, blah, blah. First thing we need to do is start a Truffle project. So that's just going to be a Truffle init, and I'm going to call this file Rentable NFTs. And that will start a project. I do want to note, if you guys were here with us last week for royalty NFTs, we had used Open Zeppelin contracts to inherit all of the royalty NFT functions. But this time, actually, it's so new that there are no inheritable contracts. We will actually be implementing this from scratch. So starting off, we're going to create 3 files actually this time. So we're going to create a contract called ERC-4907. So this particular contract is going to just have the interface definitions. So if you guys weren't here, I'll just briefly touch on that again. What the way to implement an ERC is basically to implement all the functions defined in the proposal. And an interface typically in Ethereum is just going to be signified by putting this I in front of it. So I'm going to create this contract. I did this last time. You need to go into the folder. Then we can create the contract. We're going to create another one called ERC-4907. So this is going to be the contract that actually implements the functions defined in the interface. And then we're going to create one more. Let's call this Rentable Pets. And so this contract then is just going to represent your actual, NFT collection. So we're writing 3 contracts today. And then the last piece, of course, we always want to test our contract. So we're just going to call this test rentable. Well, let's just call it Rentable Pets. Create test. Nice. Okay, cool. Now let's actually open up the code and see what's going on. So just to get started, we have the contracts that we created, the migration. So this is where we define how we want to deploy our contracts. And then we wrote our tests. Some brief cleanup. Again, I had also mentioned this last week. We are working on cleaning up our Truffle init. We actually don't need this migrations file anymore. And we're going to change the deployment file to say, hey, we want to deploy our NFT collection. So that's going to be Rentable Pets, Rentable Pets, Rentable Pets. So now that all of that is cleaned up, let's actually start writing our contract. So the first thing we need to do is define this interface. This is super easy. All you need to do is go to the ERC-4907. And it's just going to be a simple copy and paste of this interface. And where am I? This is the sample code. Here we go. Cool. And oh, whoops, I'm replacing this part right here. Cool. And so that's actually all there is to implementing the interface. We won't touch this anymore. Basically, what this allows us to do is take this functions and then define it later. So now we're actually going to get into the meat of the contract, right? So this is the ERC-4907. What this is going to do is it's going to implement the functions here. So we're going to inherit those function names. So we're going to import IERC. So that's going to be is IERC-4907. Specifically, we want to do rentable NFTs, right? So in order to be an NFT, again, we have to inherit all of the methods of ERC 721. Thankfully, this is where Open Zeppelin can come in. So I'm going to download those. And after that's been imported, we can actually import the ERC 721 URI storage. So basically now we can also add this in. What this has essentially said is this contract, ERC-4907, is going to be an NFT because we've extended Open Zeppelin's implementation of the 721. And it is also going to be defining the functions that are within the interface, who has been set out by the ERP or ERC in the EIP. Okay, cool. Now let's get started into actually implementing this. So the first thing we need to do is fix this constructor. So the constructor just takes a name and symbol. And then instead of public, it's going to be passing this information up the chain. or of the contract inheritance letter to be instantiated when we instantiate the ERC-721. But anyways, that's all there is to the constructor. Super simple. The next piece then is now actually implementing these functions. To go back here, the first thing we're going to do is going to call set user. So I just want to briefly touch on this here. Update user is going to be an event. So if you read the definition set out by the ERC, essentially what it's saying here is anytime that a user is changed, so for example, that we call set user, we will need to be updating this event. So again, because this is we are implementing it, this is kind of our responsibility to follow out this spec. It gives additional information about how we identify the different users. So specifically here, if you see the 0 address is going to indicate that there is no user and there's no rentee of the NFT. I think later it also explains in this interface here, I think, where is it? 0 value explains that there is no expiration date set either. But anyways, that was a lot of words. Let's actually start implementing this. So we're going to start off with set user and change this definition here. So for those of you unfamiliar with Solidity, external is a function modifier that you put on to signify that this function can only be called externally. So that means basically, if I wanted to call this within the contract, I would not be able to do that. So in order to fix that, I'm going to call it a public, which means that this can be handled both internally and also be called by external contracts. The next piece then is to actually start implementing this. In order to do that, actually, what we're going to do is set 2 contract variables. Specifically, we want to represent the user information on the NFT in a certain way. We're going to do this through 2 variables that we create. First off is going to be a struct. So you can kind of think of that as like a dictionary. Info, address, user, uint64 expires. So to explain this, right, user is going to be the address of the user. Expires is going to be the date of expiration. If you jump into, I guess, the definition right here, expires is going to be the Unix timestamp. So it is an integer. We will be representing it that way. Just want to call out again, specifically, if you notice here, we are using uint64. The reason we do this is for gas optimization purposes. When you are creating a struct, kind of the way data is stored in Solidity means that you kind of want to tightly couple, or you want to make it as small as possible. So in this specific case, for a Unix timestamp, the smallest unit that is reasonable would be a uint64. And then the last piece right here is going to be creating a mapping. So what this means right here is we're going to say we're going to create a map that maps uint256. So this is going to be the token ID of an NFT to user info. And so again, what this allows us to do is query this map and say, hey, for this NFT, get the user information. Who is the user? What is the expiration date? Cool. So now that we have the information, we can actually start like playing around with this. The first thing we want to do is going to get the user info that we will be setting. So user info, and then we're modifying it. So this needs to be the storage version of it. Users token ID. Where was I? Okay, so then the next piece then is to simply just set who the user is. So info.user equals user, info.expires equals expires. So at this point, you might be like, hey, Emily, wait a second. What if like this like NFT has not been added to users yet? That's a great question. The way Solidity works actually is it will return a struct with the default values. So specifically here, when you return a user info with the default value in Solidity for address is the 0 address. So that's like 0x0000. And the default value for an integer is going to be 0. So for example, if I had queried this before I was setting any of this information, both of these would be 0. So cool. That's set user. Again, really easy. The next piece then is to implement this guy right here, user of. Cool. And again, I'm going to be modifying this to be external. We'll change into public. It is going to be, oh, actually, sorry, backtrack. Again, you guys can see me make all the mistakes. I do need to add some additional function modifiers. So specifically for set user, I also want to call it virtual. So virtual indicates that if a contract was to inherit ERC-4907, they have the option of being able to override set user if they so desire. And then the last piece here as well is we are overriding this function. So we're just going to call override here. Cool. And in the same way, public view. So view means it's a calling. We're going to return information. And again, I'm going to call that it's virtual so that it can be overridden. And we're overriding the interface function, and it's going to return that address. So if you read the definition of what this function is supposed to do, essentially gets the user address. 0 address indicates that it's null. What we're going to do is, and then it also says, or the user is expired. So that means when we implement this, we need to check that the expiration date has, whether or not the expiration date has passed. So in order to do that, let's just call an if statement. So basically what we want to say is if the expiration date has happened, has not happened yet, we want to return the user. So in order to do that, we're just going to call users token ID dot expires is greater than or equal to block.timestamp. So that just says like what the current time is. One thing to note is block.timestamp is actually a uint 256, but we had defined this as a uint 64. So gotcha, gotta cast this, right? So uint 256 is greater than or equal to block timestamp. And if this is true, then we can return the appropriate users, token ID dot user. Otherwise, as specified, we return the 0 address. Cool. And that is all there is to the function user. And the last function that we need to, well, actually not quite the last, that's a hint, is going to be this user expires function. So again, change this to public. I'm going to add virtual and override. And then again, the idea is it's going to return the expiration date of the NFT. Returning 0 indicates that there was no user for it. And return the user expires for this NFT. So basically, again, this is super simple. Token ID dot expires. So basically what this is if there was token ID in here, or if this NFT had never had a user, again, if you remember what I called back to, it just returns the default value of what an integer would be, which would be 0. And so that properly fulfills the specifications laid out in this ERC. Cool. And then the last piece actually to make this correct for an interface is being able to signify that this actually is a 4907. And so in order to do that, we need to both inherit ERC-165. So ERC-165 is the interface standard. And what that does is basically standardize the way an external contract can say like, hey, how do I check whether or not you are like an NFT or you're rentable or like you have these functions? Well, you can call this function called supports interface and it'll return true or false. So basically, ERC-1721 from OpenZeppelin already overrides this function. So we actually need to override it again. So I'm going to call it function supports interface bytes for interface ID. And it's going to be public view virtual override returns bool. And essentially what it's going to do is when a external contract is going to call the supports interface and it's going to ask like, hey, does this interface ID match blah, blah, blah. So in this case, does the interface ID equal the interface ID of an ERC-4907? Or maybe they want to check, you know, is it an ERC-721? That's defined in the ERC-721 URI storage that we had inherited. So we can just call a super.supports interface ID. I'm going to stop right here and actually explain this part. You might be asking like, wait a second, we never actually identified interface ID. Where is this coming from? Interface ID is actually defined in this really nifty way. It's basically like, it's complicated to explain, but you can think of it as a kind of mathy way. So hashing all of the definitions of these functions into a unique number. So that means essentially any contract that defines its methods exactly the same way as the specified interface will always produce the same hash number. And so we can just check against that to see that, you know, it does fulfill that responsibility. Cool. So that's everything to do to specify it as a 4907. However, there is one final function we need to implement that is not on this interface. So if you remember right here, it says that we are going to need to submit a updated user event whenever we change the user. In this specific case, we want to make it such that if our NFT changes hands, so for example, if I'm the owner of the NFT and I sell it to somebody else, I'm going to say, you know, logically, it makes sense to me that I don't want a user on this NFT anymore. Basically, like the rental agreement kind of disappears if I sell my NFT. So that's the logic I want to implement. This is going to be personal to this definition here. If you don't think that that's the correct way to do it, that's kind of player's choice, dealer's choice, and you can ignore this part. But anyways, if I wanted to implement that function, essentially what I can do is override a function called before token transfer. So in OpenZeppelin's implementation of ERC-721, they have this thing called before token transfer. And so essentially, it's just called anytime a token might be transferred. So in Mint, in burn, so if I'm transferring the NFT from your address to the null address, or the actual transfer function, I always want this to happen. So then basically, if I want to, I guess, reset the user info anytime a token is transferred, I can just override this function right here. So to do that, we just need to do function before token transfer. Oops. This is not an external function or a public function. It's just going to be called internally. So we'll keep it as internal. We are overriding it and making it virtual so other people can override it. Address And then this is address. This is uint256. Okay, cool. Now, all we need to do is, hey, before the token transfer, I want to have the same behavior that it did before. So from to token ID. And then the last piece then now is when this happens, I want to delete this user info from my mapping as well as emit the update user event. However, there is one thing I do want to note. We don't want to waste gas to emit this event or delete it. So we should ensure that this is only happening if there's an actual token transfer happening. And to explain that, imagine what if you were just like transferring it to yourself? I don't know why you would do that, but it's a possibility that that error could happen. At the same time, as well as making sure don't delete this if there wasn't even user info in it in the first place. So that's going to just be checking users not equal to the 0 address. Cool. And then now all we need to do is delete users token ID. And then again, emit that update user event. And this is going to be, in this case, because we've deleted that information, we'll be doing the 0 address and expires will be 0. That actually reminds me, I forgot to emit this event earlier. So let's go back to set user. And this is going to be emitted. So user expires. So in the case of set user, it emits an event, update user with this information. Good catch. Okay, cool. So that is all we have for ERC-4907. Now, at this point, you can create any collection that you want that inherits this contract. In this specific case, we're going to create an NFT collection called Rentable Pets. So to do that, all we need to do is import 4907 and say, hey, this is an ERC-4907. And at that point, it should have all of the functions defined here that are public. And basically change this to ERC-4907. And at this point, we can just pass in what we actually want the collection to be called, which is Rentable Pets. And the symbol is going to be RP. Cool. And the last piece is, if you guys have played along with us before or coded along with us before, we need to define the minting function as well as, actually we just need to define the minting function. So in order to do that, the way we've been creating ERC-721s is separating out the token URI information, which is going to be as a result of inheriting URI storage, as well as making sure that each NFT token ID is unique. And we're going to do that by keeping track of it through a monotonically increasing counters. So in order to do that, we're going to import OpenZeppelin's counters function. And then basically, I'm just going to copy paste some code here to make things a little faster because we are almost at time. Function mint. So this is pretty self-explanatory. Whenever I mint it, increment token IDs, mint it, set the token URI. And actually, I did want to add one more function. When I'm testing this, for example, I want to actually test that this burn function works by calling before token transfer. In order to call it, I do need to expose that publicly. So I'm just going to call burn uint256 token ID, make this public, and simply burn it. Cool. And now we have all of our contracts done. So what we've done is created the interface, created a kind of base implementation of it that defines the contract with this type of implementation, as well as saying if you inherit this, it's also going to be a NFT, and then created a collection that actually, I guess, grabs all of those properties. And the last piece is to actually test this. So I am almost over time, so I'm going to do the same thing and just copy a big hefty test in, and then we'll step over it together. Cool. So let's go into Rentable Pets. Just going to copy paste this here. So there's a lot to digest here. Let's start from the top. So specifically, OpenZeppelin has a really helpful test helper library that will abstract away some of the testing for us. Specifically, there are a few pieces that I want to look at. Whether or not this part, oh, I also forgot to do this. This is perfect. So in my test, this is why we have the kind of back and forth. In my test, I test that this will fail if the person trying to set the user is not the owner. So basically, I'm going to say require is approved or owner message.sender. And the error message is going to be something along the lines of like ERC-721 is not owner nor approved. So transfer caller is not owner nor approved. Sorry for that backtrack. It was a little confusing. So basically what this does is in my implementation, I want to ensure that the only person who can decide whether or not an NFT is renting is somebody who is approved to do it or is the owner. So diving back into the test now, test helpers provides a nifty function to actually test whether or not that requirement failed or not. Test helpers also provides a nifty function to help us identify whether or not an event was emitted or not, which is an important part of, I guess, testing this rentable NFT. So that's why I have this here. So I'm just going to go ahead and import it at OpenZeppelin/test helpers. If you notice here, I use save dev. That's because basically I only need this package in my development environment. Cool. So as that's loading, let's go ahead and start stepping through this test. There are 3 scenarios that I'm testing for. So first off, we want to check that it does properly pass those 721 and 4907 standards. The second piece is checking that required part. So calling set user and making sure that it didn't do anything and failed that required part. And then the third test that we wrote here is actually testing that the user info was correctly set when we set it, as well as when we burn it. So I'm going to just quickly run over this to make sure that everything was nifty or working correctly. And then I'll actually dive more in detail to each test that I wrote. So in order to test this, we need to bring up a local instance. So I'm going to bring up Ganesh through the UI. Again, you have your choice of opening it through the CLI. You don't actually even need to open up a separate instance. You can just run Truffle test. I prefer to look at the UI version. So here, 7545 is the RPC endpoint. I need to actually modify this if I want to call it. So go to networks. Whoops. Um, 7545. Cool. And then after that, we can now call a truffle test. And if everything goes right, I won't have to. Cool. Nice. Okay. It did pass, which means I can now step over this in detail without having to fix anything. So the first piece, again, is checking the ERC-721 and 4907 standards. I got these hashes because they're defined in the proposals online. So very simple. Both of these should and they so our supports interface is good. Second piece is expecting that nothing was set if the owner was not approved, or if the sender is not the owner or approved. And specifically here, you can note expect revert is the OpenZeppelin test helper that will check for the require failure. The other piece now is to actually say, what am I checking? I'm checking this call right here. So normally, if I'm calling set user, it's just going to be calling from the first account in this list, right? And that is the owner. So in order to fake a failure, you can actually pass in this extra fourth parameter that you can like override those message values. So in this case, if we want to override message.sender, we just say from, and we're saying instead of from like the default account, which is account 0, we actually want to fake it and say, hey, this is coming from accounts 1. And then the second piece is when this is called, we expect this error to happen, which is what we defined. And it passed, so it did. And then the last piece as well is because it was not set, we want to make sure that the user info for that token ID is kind of null, right? The 0 address as well as the expiration date being 0. And so that's what it's doing here, is calling these caller functions and then asserting that it's true. Now, the last piece is the biggest, I guess, piece of the test is going to be basically testing for 3 cases, right? So number 1, we had the logic for if it's expired, return the 0 address for the user. Otherwise, if it's unexpired, return the correct user. So I just defined a few of the constants here. These are Unix timestamps again, so expiration date past, expiration date future. Minted those NFTs, set the user info, and as expected, expired NFT user should be returning the 0 address. The date is actually set, so it will return the expiration date past. If it's, and then this one right here is an expect event. So again, this is an OpenZeppelin test helper. What this essentially does is checks the transaction receipt for an event and make sure that all of the values are correct. So in this case, right, if I have an expired date, I'm expecting update user with all of this information, which is true. And again, for unexpired NFT user, it's not expired, so I return the actual account, and that is gonna, I guess, pass because it did. And then the last piece, right, is we burned the NFT, which means it should have called our overridden before token transfer. In which case, now what we expect is that that information is no longer there. And so when we query it, 0 address, as well as the expiration date is 0. And the last piece is, again, expecting that update user, where now it's token ID is 3, but it's gone. It's the 0 address and 0. So we are basically at time. I'm not going to get into additional parts. If you did want to deploy into Infura, which is really nice for actually, testing it in both the testnet and deploying it to mainnet, you would just do that by defining an environment. What do you call it? An environment function file that takes in your private key as well as your Infura IDs. The guide that I will be posting later today will have that information, so you can go more in depth. Kind of my experience in writing this contract or this test, I just want to briefly give an example of what really helped me, is you can actually do a truffle test debug and step through this code. So specifically, when I was writing this, I had a really big problem with I messed up the way I called user of. So if I said like, hey, I'm actually thinking like this particular function was weird. So specifically, I think it was like failing here. And I was like, why is this failing? Is it getting the correct information? You can do a truffle test debug. I'm saying I want to look into this specific call. And you can interact with this debugger through the CLI. So basically, I was like, okay, it's happening in call. In the user of, that's what I did, right? User of, I want to start actually looking here at line 35. So in order to do that, I can set a breakpoint ERC-4907, line 35. Okay, got a little confused. So I'm going to be, what did I say? 35? Okay, so it's set a breakpoint there. Then I can click C to just go to my breakpoint, and you'll see I'm right here. I can view all the variables. So at this point, nothing's in users. Token ID is 3. This is all expected, right? And so this is a really nifty way of like stepping through your test code. And then I can just go to the end. And that's my test. If you remember last week, I did touch on the visual debugger with VS Code. I do want to note the visual debugger currently only works with in an actual kind of deployed environment. So in this case, when I call truffle test, it kind of has a clean test instance. Our visual debugger is not able to read into that yet. It will in the future, but for now, if you wanted to use the visual debugger, you would need to do a real migration. So in this case, a truffle migrate will do the default deployment. You can see here the deployed contracts are actually all over here. And you can either write a script or interact directly with this guy and like do stuff like contract equals rentable pets dot deployed. And then what's next? Contract dot mint, I think, is a way to do this. Oh, whoops. Cool. And then because this was done on an actual deployed contract, I should be able to see and like dive into these. If you notice here specifically, there's no class name in front of it. That's gonna, the visual debugger is not gonna be able to read into this because these contracts were deployed within a testing environment, whereas these were interacting with actual deployed contracts. So you can like step into Mint and go look around like this. So yeah, that is everything. I'm going to stop sharing, head back to the actual stream. Are there any questions? Okay, cool. There are quite a few questions. Let's start from the top. I'm going to bring this into the chat. Okay, so what is the, if you look in the chat, I'll just go ahead and read it. So there was a question here. What's the key point about rentables? Old Snaky replied, NFTs will have utility. People will want to rent NFTs for their utility. And it makes it easy to do it permissionally and interoperable. So to expand upon that point, right? Yeah, I'm the owner of an NFT, but say I'm not using it, or I guess a really good way to explain it is like renting land. Land has utility to interact with. And so even if I'm the owner of the land, for example, in Decentraland, maybe I don't want to build anything on it, but you want to actually use my plot of land to build something on top of it. I can just give you that utility by separating the concept of owner and user, right? So I will still own it, but I can, if you are set as user, then you can use it. And that allows that kind of separation of, utility versus ownership. So you don't have to give away your NFT in order for someone to use it. Let's see. The other question is right here. Also another one. So does it have a label on the original without transferring? Yes. So if that what you mean by, if by label you mean like knowing who is the owner and the user, then I guess to reiterate the point, the NFT will have two addresses. So if you saw in the implementation, I had that user info to set the user address. The second piece actually is like the owner. In my implementation 4907, you didn't see me set the owner. However, that ownership is set already by the ERC-721 standard. So it has both of that information there. Yeah, so good question. Is there a use case for Rentable to have multiple users at the same time? Yes, that is possible. Again, that is going to be up to you to be able to implement it properly. If you can think about it in this way, I don't know how to do it, but kind of off the top of my head, if I were to think about it, would be, if you remember when I was implementing user info, I only specified one user. You might be able to like manipulate that info so that user is what do you call it? Like you might be able to change it around such that the way it's stored might store like an array of users. Maybe another way you could do it. I'm just throwing out ideas. None of this is correct. Please build it on your own and let me know how it works. Might be like a multi-sig wallet. Yeah, but if you're asking about like use cases, Old Snaky had commented here. Yeah, if you want like maybe multiple subscriptions, I don't know, decentralize your NFT or your Netflix account. That is maybe a possible way to do it. Okay, cool. What's the difference between public virtual override and public view virtual override? Okay, good question. I'm gonna share my screen again so we can actually look at this code. So line 44 and 48. 44 and 48. Okay, so in this specific case, actually, wait, yeah, it needs to be view. Sorry. Wait, oh, no, it is there. You asked me what's there. There's no difference between these two. I just had a different ordering. Public view. Oh, actually, yeah, okay, there we go. So I guess to explain view, view basically signals that this is going to be a getter function. It's getting expires. It's getting a Boolean. In this case, it's also getting the token ID. Sorry, not the token ID, the user address. So before I put it here, the order doesn't matter. But yeah, okay. Going back to the questions. Stop sharing. What is this? What's the difference? Okay. It's the same question. Yeah, sorry. I just typed it in a nonsensical order, but it doesn't matter. Poor pets, they need forever homes. That's true. Yes, okay. Private key. Do you want to see my private key? I will not give you my private key. But I had touched on this last week as well. I will keep hammering this home. If you want to deploy, let's say like quickly without having to do this environment variable stuff, Truffle has this thing called Truffle Dashboards. Whoops, I don't know what I did here. Let me just play. Okay. Cool. Clear. I can open up a Truffle dashboard. And this will open up my MetaMask wallet. So if you go here, confirm, you can choose kind of what testnet you want to go to. So in this case, Rinkby, I have it currently. You should be using Gurley. I had mentioned this before. We are going through the merge right now. If you guys haven't been following, Gurley testnet was actually merged, I think like 2 days ago or very recently. So you should be using Gurley as your testnet. But essentially now, instead of deploying through like Infura, well, this actually still deploying through Infura, never mind. You can just do a truffle migrate network dashboard. And then you can compile your contracts. And this is the deployment right here. So I hit confirm. And this is a test net, so it might take some time because it's, I guess, with the public using it. Oh, I'm not sharing my screen. Oh my goodness. I always do this. Okay, cool. To go back, what you saw was Truffle Dashboard essentially is a way for us to deploy through MetaMask. So I'm just going to show it again. I just called the Truffle Dashboard. It brought it up on 24012. And you can select what testnet you want it to be, or you can also deploy to mainnet through here. And then just to deploy it again, I'm going to deploy it through dashboard. And as you can see here, I can just sign my transaction. And so you can do this with like minting, setting that user, all of that requires a signature. I do want to, for testing and deployment purposes, the dashboard is really great for deploying. But once you get to the point of, actually writing the test. So if you look here, we have we're sending multiple transactions. Like we're going to be setting the user multiple times. We're going to be minting multiple times. In a development process, that becomes a lot of overhead if you are trying to sign each of those transactions through MetaMask. The way I prefer to do it is through Infura at that point. So it just automates everything. That means you do have to publicize your private key. So kind of another tip, well, publicize in the sense that you actually have to write it down on your terminal or your IDE. Tip for those, I have a separate development wallet, separate from, I guess, my real wallet where I actually have real ETH and everything. So again, you should definitely do that. But the other piece actually as well is if you want to test on an actual test environment, on a testnet, for example, but do it locally, because that's way faster, right? You can actually fork mainnet, testnet, whatever you want with Ganache. So there's multiple ways to do that as well. You can do it through the CLI, or you can do Ganache fork Rinkeby. You could also do it through the VS Code extension. Whoops. If I, for example, disconnected this, if I wanted to create a new network, I can also do a fork, mainnet, Robson, whatever. Dealer's choice. Again, you can also do it through the Ganache UI. Don't remember where it is. Cancel. Is it an advanced chain? Yeah, so you can fork different things. Yeah. But anyways, oh, here we go. Chain forking. And then this is where you would put your Infura URL. And then you can also select on the block. So if you don't want to, for example, import or fake the data from the entire history of the blockchain, you can choose the specific block that you want to start at. Okay, cool. I hope that explains that piece. And then what's the last question? I think that if there's no more questions, then I guess we are good to go. Last piece here, if you want to stay connected, follow me on Twitter. Follow me on Truffle Suite, or not follow me, follow Truffle on Truffle Suite. Again, this is episode 2. If you were here for the whole stream, there were so many technical difficulties. That's fine. We are learning together. And the last piece then is to, I guess, continue on with the series. If you want to kind of get an idea of what's coming up, Web3 on Web3 Unleashed next Friday, we are actually bringing on a guy from Open Zeppelin, my favorite like contract creating company. It's so useful to actually talk about smart contract upgrades. So, you know, again, I think I had touched on this before. Upgrading smart contracts, there's trade-offs, right? So like, is it worth it to fix a bug versus, you know, the by nature Ethereum is supposed to be immutable. When do you decide to upgrade? When should you not? And so we'll be talking security trade-offs with him next week. I think the week following, we'll actually be building, like doing an upgrade together to show you how it is. And then like various things, right? Like Viper, I'm really excited about. We have a call with Live Peer coming up. So if you guys are interested in decentralized video streaming, that's really cool. So anyways, keep in touch. I will, hopefully these will go smoother as we work out the kinks in new tech. But yeah, okay. Have a great day, guys. This was awesome. I hope you guys learned a lot. Replay it, share, do whatever. The more audience we have, the more questions, the more we can go over stuff. Okay,